Hi everyone, this is Jayashree, Assistant Professor, Department of IoT. So in this lecture, we discuss upon various data structures, various different types of data structures in R programming, right? So we have discussed in the last class, we have in the last video, we have discussed about how to install RStudio, and we have executed various arithmetic operations and various 1 2 3 programs. Okay, right. So main objective of today's this video is learning data structures in R programming is to understand how to effectively store, organize, and manipulate data for statistical analysis and program tasks. So we are going to learn various data structures in our programming, right? To select and apply the most appropriate data structures for different types of data sets, ensuring accurate and efficient data handling, right? To develop the ability to write clean, optimized, and flexible R code by leveraging the strength of each data structures in real-world data analysis. So this is the objective of today's class, right? So next, so in data structures in R has 6 types of basic data structures, right? So we can organize these data structures according to their dimension. So it is a single dimension, 2 dimension, and n dimensions. Okay, multi-dimensional data structures are there. Okay, so we can also classify this as homogeneous and heterogeneous. So homogeneous data structures contains same single type of data. For example, integer means it homogeneous data structures contains only integers, right? If it contains characters means it contains only characters. So homogeneous and heterogeneous data structures contains a mixture of various types of characters, numerals, and strings like. Okay, homogeneous data structures are ones that can store more than one type of data at the same type. So that is heterogeneous. Overall, there are six R contains or has 6 types of basic data structures, right? So look into this picture. See, here I have given 5 major data structures. So there are main 6 data structures I have listed in the left side: vector, list, matrix. Fourth one is data frame. Fifth one is array. Sixth one is factor. Okay, right. So what is a vector? We discuss upon one by one. We discuss all 6 data structures in this video, right? So look into this picture. What is vector? Vector is a single dimensional data storing element which which stores a single one type of data. This is homogeneous data. Vector stores only homogeneous data. Okay, right. Then look into the second one, list. Look into the colors. So this list can store multiple data, various types of data. So it holds it can store heterogeneous data, various types of data. Okay, right. Then look into this matrix. Matrix is two-dimensional. Okay, right. So the two-dimensional storing element contains rows and columns. Then look into this data frame. What is data frame? It is a collection of vectors of various data types. Okay, right. So this is also heterogeneous. So data frame is contains collection of vectors which are arranged column wise. Right. Data frame. Then fifth one is array. So array is like it is a collection of matrices. Right. So it contains various stacks of matrices and stores data like a pile, right? We discuss upon this one by one. So here, what is as I already told, vector are a single dimensional. So to create vector, we have to use a C function. So C function we use to create vector. So here I have given the RStudio console. So look into this program vector. VEC is a vector, name of the vector assigns to C of 1 2 3. Okay, C is a function. So 1 2 3 are the data assigned to the C function. Okay, so this is a simple coding. Okay, if you give enter, okay, if you run this coding vector, what is the output? Output is 1, 2, 3. Okay, right. So look into the environment column. So there are three numbers 1, 2, 3. Okay, it is a vector of same type, integer type. Right. So C is the function to create vector. So we can also use assign function. This is another way to create a vector. So assign, can use assign. Name of the vector, assign. Name of the vector is vec2 here. C of 4, 5, 6. So here also there are three elements. 4, 5, 6. Okay. The vector name is vec2. So you can use assign function also. So also vector holds the same type, single type of data. Okay, right. So similarly, we can create n number of vectors of various types. So a vector can be created using numerals, integers, logical operations. Logical vector is also possible. That is logical commands like true or false also possible. Complex vectors. Complex vector contains complex number. For example, 12 plus real plus imaginary number. 12 plus 2i, 3i, 4 plus 1i. Like this vector can be created using complex numbers also. Characters also can also be used. But mixture of different data types is not possible. The vector is to be created with a single type. Okay, right. To use this command, what is our output? Output is a numeral, integer, logical vector, complex vector, and a character vector. Okay. So that's all about vectors. Next one is lists. The lists are heterogeneous data type or heterogeneous data structures which can store all types of data. To create list is the function. List function is used to create list. The list of any numeral, any string, any vectors, any logical operators, complex number, integers. So list holds all data types. Then third one is matrices. So matrices are two-dimensional homogeneous data structures. Okay, right. So this is the syntax of matrix. Matrix of data, n row, n column, by row, dimensional names. Okay. So data is the data input value, number of rows, n column is number of columns, by rows the logical, which tells the function to arrange the matrix, whether it is a row wise or column wise. Default is column wise. Okay. Then dim names is a list of names for there is row names and column names. So look into this coding. So here matrix of C is C of 1 to 9. So there are 9 elements. N column equals 3. So now there are 3 columns and 9 elements. Look into that output 1, 2, 3, 4, 5, 6, 7, 8, 8. This column wise 3 numbers are arranged. So this is the basic syntax of a matrix. Okay, right. We can create matrix with row names and column names also, right? So we have to assign row names and columns names. We have this is the assignment operator. Assignment operator C of row 1, row 2, row 3, column 1, column 2, column 3. We give this, the output will contains the matrix will contain a row name and a column name, right? So next one is data frames. Data frames are two-dimensional heterogeneous data structures, as I already told, right? So to create data frame, data dot frame is a function, right? So look into this data frame. So data frame contains heterogeneous data. It is of various vectors. So here there are 3 vectors. One is student ID, student name, and student rank are 3 vectors. So here data frame is created. Look into this coding. Student.data is the name of the data frame. The function is data.frame of vector 1 student ID, vector 2 student name, then is student rank. Okay, what is my output? Output contains 3 vectors, student ID, student name, and student rank. So this is about data frame, right? What is an array? Array is three-dimensional. So array is three-dimensional homogeneous data structures like matrix. The function is array function, array of data, dimension, names. Okay, right. Look into this array. So array of C of 1 to 18. So there are 18 elements. Now it is my dimension. Dimension equals C of 2, 3, 3. Okay. There are two rows. There are two elements, three columns, and three sets of matrices. There are three piles. Okay, there are three piles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it is arranged like this. So dimension C of 2, 3, 3. So what is 3 is data, dimension, and dimension name. Right. Third one is, last one is factor. Factors are vectors that can only store predefined values. So look into this. Factor C of A, B, A, B, B. It is my factor. So factor is A, B contains only two values, either A and B. There are two values. Okay, levels. These are set of allowed values. Set of allowed values is only A and B. So here factor is created using factor function, right? So today the summary is we have discussed upon various data structures, 6 different basic data structures: vector, list, matrix, data frame, array, and factor. Okay, this is a storage element. These are for storing for various types of data. I come with another new topic in my next video. Thank you. Thanks for watching.